What happened? One more difference.
So we just have one that's similar to the one we got on the test.
Say it again.
We just have one that's sort of similar to the one we got on the test.
Certainly. Now you should realize that in this section there's only so many to choose from.
Yeah.
So I would practice them well.
Just put everything up that's on the test.
I don't remember what's on the test. See, some remember exactly. I'll email it to you after you take it though. Let's see here. Number 38. Oh, those look like a little bit. So just straightforward, you know, X, Y, Z, Z, B, C. It's a little bit of a challenge. Next one is the root of x squared plus 4x. So first thing we'll do is see if it is an indeterminate difference. Yeah. So this heading towards infinity, and this is heading towards infinity. The root of infinity is infinity, so it is an infinity. Or 8. That's a root of infinity. Infinity minus infinity case, it is. So now we need to try to construct a quotient out of this. There is another way to approach this problem.
Times x plus square root of.
Say it.
Times x plus.
Exactly right. You could apply the conjugate of this expression to top and to the bottom, which is not there. You could do that. Right? You should keep that in mind, actually. Okay? If we get stuck on this, this is exactly what we're going to do, because it'll knock it out actually faster in this case. Yeah, but then it won't. I want you to get practice writing this as a quotient. I guess I'd write it as a quotient. It'll be a quotient.
Yeah, let's do a quotient.
It'll be a
All
quotient.
that's over one.
It'll be a quotient. Let's do it. It'll be a quotient. It's a good idea. Perfect. So multiply by the conjugate. X squared plus 4x over x plus the root of x squared plus 4x. So now simplify the numerator. So remember that since they are conjugates, all you need to do is take first times first, so that's x squared, minus second times second, but all that does is clear the radical, right? You just have the radicand, x squared plus 4x. Make sure you put it in parentheses, x squared plus 4x. And the bottom is whatever you had. X squared is canceled, and you're now left with negative 4x over that denominator. Okay. So if I were not L'Hopital, which I'm not, what I would do is I would take out an x from everything right now. And that would be the game I would play. And that would be the game you would play if you didn't want to take derivatives top and bottom. It's certainly a 0 to 0 case. I'm sorry, infinity over infinity, right? Everybody agrees with that. We've changed it to an indeterminate quotient, right? Granted, the top's negative infinity, but that doesn't really impact the problem at all. As I said before, it doesn't matter which sign it is, right? It doesn't matter. So we can take the derivatives top and bottom now, if you want. Apply L'Hopital's rule directly. Do that? Game? Okay. That's what if you pull an X, the problem will be over already.
Did you do the conjugate?
We did, exactly what we did. We did conjugate. Top and bottom. That's why we multiplied this out here. I didn't FOIL it out. I knew it was going to be first times first minus second times second. If you take it on x right now from every term, the problem is over. If you take an x, you look really sleepy. If you take an x from every term right now, the problem will be over. Okay? And this is what you would have done back in 2 point whatever it was. Right? The difference now is you could apply L'Hopital's rule if you want. I think it's actually more fun. So let's do it. So we'll have a little more space here.
When you say you pull out an x from everything, you mean from the top and the bottom, right?
That's correct. And include that radical.
Oh, include the radical?
Yep. gotta do it for everything, every term. There's 3 terms: the negative 4x, the x, and the radical. So we'll have lim, according to L'Hopital's, take this derivative. We'll have a negative 4 above. Anytime we have a constant, that's great. X approaching infinity. The bottom is going to be 1 plus the derivative of that expression. Say it again. 1 plus 4 over.
If you pull out an
This
x,
thing?
right? Yeah.
Oh, I didn't pull up the x. I'm gonna pull up the x.
Oh,
If it had the x, we don't have to do L'Hopital's rule. I want to do L'Hopital's rule, just demonstrate L'Hopital's rule again on this problem.
I thought you were pulling out the.
No, if we do, then because how it looks. I see what you're saying.
Yeah.
Yeah. These are the derivatives. It looks very similar, doesn't it? Right.
Yeah.
Okay. So we have negative 4. We have a 1 for the derivatives, and now we need to take the derivative of this piece. So if that's a 1/2 power, then you're going to get 1 over 2. It's going to go down to a negative 1/2 power, which puts it as a root in the denominator, times the derivative of the denominator, which is what? 2x plus 4? It will look like that. Any disagreements? I know you can factor, you can cancel the 2.
Wait, would it just be 2? Because
This whole thing here is 2.
No, the 2x plus 4 wouldn't it just be 2 because you have to take the derivative of what's inside, right?
Yeah, derivative was inside, so 2x.
Oh, it's x squared plus 4. Okay.
Yeah, it's an x squared this time instead of radical. Yeah. So let's just see now what's happening as x goes towards infinity. Certainly negative 4 and 1 are unchanged. So as x goes towards infinity, in this expression, it's an infinity over infinity case. So you could do L'Hopital's rule on this piece alone if you wanted, right? If you wanted. So the problem with this, I don't know if you guys realize, I don't see what's going to happen. If you do L'Hopital's rule on this, although the 2 will go to a constant, right? It means 2x plus 4 will go to 2. But down here, you're going to take the derivative of radical again. So what's going to, and it's got this x squared plus 4. You're going to get the same derivative again. So there'll be another indeterminate quotient, another indeterminate quotient, another indeterminate quotient down the line, right? We'll keep doing that. So we need to evaluate it now without using the indeterminate quotient aspect. So we'll now take it, now that we see that's going to happen, it's going to be a repeating process like that. If you do it one more time, you can certainly see it. I just don't want to do it again. So you should now take out a factor of x and evaluate it in the old-fashioned algebraic way, right? Why should you keep running circles? It's going to keep happening over and over again. So just analyze this piece alone. Limit, we're going to, I'll leave the 2, it doesn't matter. So 2x plus 4 over 2 the root x squared plus 4x, x heading towards infinity. So if you now factor off an x from every term, I read x times 2 plus 4 on x, that's the numerator. You guys remember this technique?
Yeah.
Great. Renee, are you lying?
I'm not lying.
Good.
I was telling him about it earlier.
Oh, yeah? All right, good.
He said what?
So be careful now with x. See if we can remember how this works here. How's that? Is that right?
That was right.
Wait, what did you do?
I took an x from top and bottom. So when you factor up the x from here, the 2 is left by itself. But since the 4 does not have an x to take away, we must introduce it underneath.
Okay.
Same thing here. Now, when I take the x out of here, if I want to take an x and get an x out here, I got to take an x squared from in here, right? This is the root. Root of x squared is x. So